Myself, Kokila Vani from the Department of Information and Technology. I'm going to teach an overview of data structures. What is a data structure? First is a data structure is a way of organizing and storing the data. So it helps in efficient data access and modifications, and it also improves the performance of the program. And it is essential for software development and problem solving. Then next one is why we need for data structures. It used for efficient use of memory, and it used the faster searching and sorting techniques and easy data management. It improves algorithm efficiency, and it supports handling large amount of data. Then the types of data structures. There is two types of data structures there. One is a linear data structures, another one is a non-linear data structures. In linear data structures, the elements are arranged sequentially because the elements are stored in a continuous memory allocations. So here the for linear data structures, here the examples are array, linked list, stack, and queues. These are arranged in an sequence manners. And second one is a non-linear data structures. Elements are connected hierarchically. For example, tree and graphs. In tree and graph, the nodes and the elements are connected hierarchically. In this, array is a collection of similar data elements that are stored in the same data type, and also it's stored in a contiguous memory locations that are accessed by using their index values. It is a fixed size also. It fast access to elements. Second one is linked list. Linked list is a collection of nodes connected by pointers. The pointer is used to connect the nodes by using the memory locations. Dynamic size and also efficient insertion and deletions. In linked list, there is three types. One is a single linked list, doubly linked list, circularly linked list. The circularly linked list is implemented in the single linked list and double linked list also. And the next concept is in stack. Stack is an linear data structures, and it follows the last in first out concept, because what are the elements we put in a stack that will be picked out by the last, and the operations performed in the stack is in push, pop, and peek. Push means we insert the what are the elements we insert into the stack is called as a push. What are the element we pop out from the stack is called as a pop. Peek is used to pick up the last element, that is the last top element by pick out by the peek functions. Then the applications function calls undo operations, expression evaluation. Q is also a linear data structures. It follows the first in first out. It's like a queue. For examples, we are standing in a queue. That means the first person may go the first. That follows in a queue. So here the operations in Q is an NQ, DQ. So NQ and DQ, for examples, if the person is out from the queue is called as DQ. If the persons comes in a queue is called as NQ. Then the applications are CPU scheduling, printer queues, network data packets. Next one concept is in trees. Trees is a hierarchical data structures. It consists of nodes and edges. Next, the terminologies which are used in the tree is in root node, parent node, child node, and leaf node. The root node is a basic node. Then next one is a parent node. The parent can have many number of children in a general tree. Leaf node, that is in the last end of the tree, end of the node in a tree is called as a leaf node. Then applications, and then file systems, databases, are decision trees. And then next is a graph. Graph is a collection of vertices and edges. The vertices connected by using their edges. It represents relationships among these objects that doesn't vertices. So in graphs we have some other types. One is a directed graph, undirected graph, and weighted graphs. So in directed graph there is a direction between the edges. I use in the edges. And the undirected graph, the vertices are connected by the edge without the directions. And weighted graph. In weighted graph, the vertices is connected by using the edge, that edge having some weightage from the source and destination. And the applications, so in graphs are used in social networks, GPS navigation, network routing. Next one is in searching techniques. In searching techniques, we using the two searching. First one is in linear search, second one is in binary search. In linear search, the elements are checking each items one by one. In searching is started, that is checking with each items one by one, starts from the first element and continues until the target is found. That works both in a sorted data and sorted data. And linear search is in sequential search, that is easy to implement. Next one is in binary search. Binary search, it searches by repeatedly dividing the search space into the two halves. That in that we are using the mid values. In mid value, that is, and dividing the elements into two halves, works only on the sorted data. The binary search only implemented in the sorted elements or sorted data. Here they compares the target with the middle of the elements. It eliminates half of the remaining elements in each step. The next one is in sorting techniques. In sorting techniques, there is an bubble sort, selection sort, insertion sort, merge. These are used to arranging the elements in a sequence, like that is an ascending orders. Like here, the bubble sort. Bubble sort compares the adjacent elements and swap them if they are in the wrong orders, because the bubble sorts compare the elements by its adjacent elements. It repeats the process until the array is sorted. Then the selection sort, it finds minimum elements repeatedly. In insertion sort, builds the sorted array one element at a time. And the merge sort, so in merge sort we using the divide and conquer approach. So it divides the array into smaller subarrays. After splitting out the subarrays, the sorting technique is performed in that subarrays. After the sorting and the subarray, that are combined to get an sorted array. Next one is on time complexity and space complexity. The time complexity, it measures the amount of time an algorithm takes to execute the input size increases. It helps us evaluate the efficiency of an algorithm. This is called as a time complexity. In space complexity, it measures the amount of memory an algorithm requires during the executions. That is in space complexity. In data structures, we mainly consider the time complexity and space complexity. Thank you.